18th question. A 5000 kg rocket is set for vertical firing. What is given, children? Rocket is given for you. Something like this. Okay. Mass of the rocket is given as 5000 kg. Okay, and it is set for vertical firing. The exhaust speed is 800 meter per second. That means the rocket is moving upwards. Okay, whereas the gases are coming outwards. The exhaust speed, in the sense, the exhaust, who is the exhaust here? Gases are exhausting, and these gases are coming with a speed of 800 meter per second to give an upward acceleration of 20 meter per second. So as the rocket is moving upwards, then upward acceleration is given as 20 meter per second. The amount of gas ejected per second, amount of gas ejected per second means the mass of the gas coming out with respect to time. You are asked to find out. Okay, children. So as the rocket is moving upwards, the up thrust, let us indicate with the letter T. Okay, or F, up thrust. Okay, is also a type of force. As the name thrust is given, instead of F, I replace it with some T. Okay, the up thrust or upward force, let me replace with T. Whereas whenever a rocket is moving upwards, the whole weight is supposed to be acting downwards. So the weight of the rocket must be acting downwards, whereas the thrust, the net upward force or thrust, is acting upwards. So based on the above configuration, let us try to relate the equation. So as the rocket is moving upwards, the force is acting upwards. So net force is given by F net is equals to upward force, that is T, minus downward force, that is mg. So F net is given by T minus mg. And we know that F net is nothing but mass into acceleration is equals to T minus mg. This mg, if you bring it here, then we have T is equals to ma plus mg, or m taking out common, we are left with T is equals to m into a plus g. So what is the formula for upward thrust, children? Thrust T is given by m into a plus g. So let us rewrite in a proper order. Then T is equals to m into a plus g is our required formula. Children, we also know that suppose if mass is constant, F is given by m dv by dt. But if the speed is constant and mass is changing, then we know that F is equals to dm by dt. So we are aware of this. Mass is constant, dv by dt, m into dv by dt. Velocity, speed is constant and mass is changing, v into dm by dt. So here, as I told you that F is replaced with T, or T is replaced with F. So here, as the speed is constant and the mass is changing, amount of gas continuously is acting outwards, so mass is changing. So instead of T, I can replace with V into dm by dt is equals to m times of A plus G. So instead of this force, up thrust or upward force, I replaced it with V times of dm by dt. Now substituting the given values and solving, we have the value of V is given as the speed, the exhaust speed of the gases is given as 800 into dm by dt, amount of gas ejected per second, you are asked to find out dm by dt equals to mass. So mass of the rocket is given as 5000 into acceleration. A, net upward acceleration is given to be 20 meter per second square, plus G, value of G is to be taken as 10. So bringing this 800 the other side, we have dm by dt is equals to 5000 upon 800 into 20 plus 10 is written as 30. Now solving this, we have 2 15 times and 2 4 times, again 2 times and 25 times. So further solving will give you that So 25 into 15 is 375. So let me multiply this, children. 25 into 15. So how much is that, children? 375 upon 2. How much is that? 375 upon 2. Hence the value of dm by dt is equals to 375 upon 2 is given by 187.5 mass per time. Mass is measured in kg, time is measured in seconds, so upward means kg per second. Hence your final answer must be 187.5 kg per second. So option number 3 must be true, that is 187.5 kg per second. Okay, well, now let us move to the next topic, that is impulse concept, numericals based on the impulse concept. So what is given here, children? A small sphere of mass 2 kg is given. How much mass, children? 2 kg mass is given, moving with a velocity of 4 I cap minus 7 j cap meter per second. So a small sphere is there, and this sphere is moving with a speed of some u, that is 4 I cap minus 7 j cap meter per second. This is the initial speed. Collides with a smooth wall. Collides with a smooth wall. After collision, it will again return with a velocity, some v is equals to minus I cap plus 3 j cap. Is that clear, children? The magnitude of the impulse received by the ball you are asked to find out. Children, you know the formula for impulse as J is equals to F into T, which can also be written as mass into change in velocity. Okay, well, so we know the value of mass, we also know the value of final velocity, and we also know the value of initial velocity. So substituting all the values in the above equation, we have J is equals to mass of the sphere is given as 2 kg, final velocity is given as returns means return direction itself is given as minus I cap plus 3 j cap, and minus the value of u is given as how much, children? 4 I cap minus 7 j cap. So this minus 4 I cap minus of minus 7 is plus 7 j cap. Clear? Hence the value of j can be written as 2 times of minus I, and minus 4i can be written as minus 5i. 3 plus 7 is 10 j cap. Well, so j can be written as 2 into minus 5 is minus 10 I cap plus 20 j cap. But you are asked to find out the magnitude of the impulse. To find the magnitude of the impulse, we have to find out the root over minus 10 coefficient squares, this value whole square, minus 10 whole square plus 20 whole square will give you the magnitude. This can be written as 100 plus 400 under root. Hence the magnitude of the impulse is given as root over 500. This can be written as 5 into 100. Root over 5 keeping aside, root over 100 can be written as 10. So answer is 10 root 5 kg meter per second is your final answer. So what is the answer, children? 10 root 5 kg meter per second. So option number 2 must be true. Clear? Well, the next question. Question number 20. A ball of mass m is thrown at an angle theta. So what angle the ball is thrown? Making an angle theta with the horizontal with an initial velocity u. Okay. So this is a projectile motion. So based on the projectile motion, what is given, children? This is x-axis and y-axis. A ball is some mass m is there making an angle theta. It is projected into the air. So it takes a parabolic path, something like this. It goes into the air and comes back to the ground. So here at the time of projection, it is projected with initial velocity u, making an angle theta. This initial velocity vector is resolved into two components. Horizontal component given by u cos theta and vertical component is given by u sin theta. So the initial velocity vector is given by u cos theta I cap plus u sin theta j cap. The initial velocity vector is given by u cos theta I cap plus u sin theta j cap. Now after certain time t, it may move to some position. Say let us suppose this position. So at this position, the direction of the velocity vector will be something in this direction. And again, this can be resolved into two components, one horizontal component, the other along vertical component. And you know that the horizontal component always remains constant. This is case 1, children. Moving to the case 2, we have as a different story. Horizontal component always remains constant and this is given as u cos theta, whereas the vertical component is given by v is equals to u minus at in the vertical direction. So vy can be written as uy is nothing but u sin theta minus gt. Hence the net velocity after time t can be given as vx. So v final, this is v initial, okay, and this is v final. So final velocity is given by Vx I cap plus Vy j cap, or V final can be written as, what is Vx, children? U cos theta I cap plus what is Vy? U sin theta minus gt j cap. So this is what the case. So we know the value of the initial velocity as well as final velocity. You are asked to find the change in momentum. To find the value of change in momentum, formula for change in momentum is delta P can be written as mv final minus mu initial. Okay, so this is nothing but m into vf minus vi or ui. So whatever the name you will be giving. Okay, so as I have replaced this with ui, so let me replace it here also with ui, whatever the name you give. Hence it can be given as mass. What is the mass given, children? Mass itself is given as m. Final velocity just now we calculated as, so mass. What is Vf? Vf is written as u cos theta I cap plus this part is u sin theta j cap minus gt j cap. So this is the complete value of Vf, and here minus is there, this minus I replaced, and ui, what is ui, children? Ui is equals to u cos theta I cap plus minus and plus will become minus u sin theta j cap. Hope you understood. Okay, so let me make it clear. So this whole part is the value of Vf and this whole part is the value of ui, as minus is there, so minus after taking inside that will become minus. Is that clear? So Vf is written by u cos theta I cap plus u sin theta j cap minus gt j cap, and this minus symbol ui is nothing but u cos theta I cap plus u sin theta j cap. That's it. So further solving gives the delta value, change in momentum is equals to m into this. If you remove all the brackets, then how much it will be? U cos theta I cap plus u sin theta j cap minus gt j cap minus u cos theta I cap minus u sin theta j cap, minus I took it inside. Hence This is u cos theta I cap and here minus u cos theta I cap. This is u sin theta j cap and here you have minus u sin theta j cap. Well, hence the leftover value will be delta p can be written as m into what is left here children, minus gt j cap. This can be written as minus mgt j cap. The value of change in momentum is given by minus mgt j cap. That's it. And if you would like to find out the magnitude of the change in momentum, only if you would like to find out the magnitude of the change in momentum is nothing but here magnitude of this is given by mgt. Magnitude of this is given by mgt into here minus is also there and j cap is also there. I can write this as, first of all, change in momentum delta p, I'll write it as mgt into minus j cap. So this minus j cap indicates the direction of the change in momentum and the magnitude of the momentum change in momentum is a mgt. So its value is, the value of change in momentum is mgt in which direction? J cap indicates y-axis, minus j cap indicates negative y-axis, that means downwards. So its change in value or change in momentum is mgt. How much is that? mgt acting vertically downwards. So this is the complete answer. mgt vertically downwards. So option must be option number 1, that is mgt. If they are asking for direction also, it can be given as vertically downwards.